Jim McGregor here for TIRIAS Research and another TIRIAS cast here at SC25. I'm here with Tyler Morton. He is the Senior Director of Storage for OEM and Mid-Tier Cloud at Micron. And, you know, Tyler, I even really hate to talk about memory and storage independently because as we've seen with HPC and AI applications, you know, it's really a single data pipeline. They have to work together. I mean, we're even talking about, you know, GPU attached storage, you know, plus SOCAMs that are, you know, right next to the host processor and all these things. I mean, it's a very complex memory and or complete data pipeline to actually feed the beast, if you will. So what, you know, how do we really improve that storage part of it to get more of those very large language models and very large workloads, you know, faster and faster into whether it's the processor or the accelerator?
Absolutely, you nailed it on memory and storage, both critical, and that's where Micron, that's the root of our advantage and why we lead the industry, is your DRAM technology nodes, the base DRAM and the base NAND nodes. So I'll focus a little more on the NAND side. If you don't have that, if you're not leading on the technology node level in the market, then the products that you put out will be reflective of that underlying technology, and that's where we really have a leading advantage in the market. So on the NAND side, with our G9 NAND, we're the only one ramped in data center SSD with 9th generation 3D NAND. And with that leadership in NAND technology, that's where we put out leading edge products. So I'll focus maybe on our 9550 today for HPC. So it goes up through 30 terabytes and is also high performance. So it's not high performance or high capacity. We can size high performance anywhere needed for the HPC space.
But not just that, but it's also very power efficient, correct?
Absolutely. So again, one of those underlying requirements for HPC especially is power efficiency. Power is becoming more and more critical in the data center, reducing power where possible, and that NAND technology is really the root of what that SSD looks like. So leading on the NAND space and then driving that into leading edge SSD designs gets the power down, power efficient SSDs with top end performance. And with that NAND, that 9th generation 3D NAND, we've now made our first PCIe Gen 6 drive, and it's the first in the industry. So we love leading in the space. We're going to keep on it, not just at the NAND level, but also at the drive level.
Now at FMS, when I was talking to Jeremy, he was highlighting the fact that, you know, AI is really not, and the processor guys are talking about it as 2 workloads, encode and decode, but everyone else in the memory industry looks at it kind of as 4 distinct workloads or 4 distinct segments when you're trying to do an AI processing. How does that translate from AI to HPC?
We're seeing a bit of a convergence, right? Because there's a singular global portfolio of storage products and memory products out there. And with the weight that AI is having, there's a constant push and pull of, can we converge those requirements into the best solutions that fit everybody's needs? And AI is a challenging one because there's such a wide range of needs that are out there. And that's why we have such a broad coverage portfolio. So you have the large training clusters. Think of the very attractive, gets a lot of attention, right? Lots of our HBM in it, large training clusters, all the way down to the end inferencing, which is where the market's really emerging and there's a lot of growth potential over the next couple of years. You think of our favorite analogy is the back of a Target, the back of a Best Buy. That old server, the old workstation that was behind those retailers has been relatively the same for the last decade, 2 decades. Now that server in the back of a retailer is going to look drastically different 5, 6, 7 years from now at all the retailers because the capability, the AI capability at the edge that will be driving. So depending on the scale or the range of AI application, it might be our high performance drives, or it could be even our mainstream drives that satisfy the needs depending on where that application is set at.
Yeah. And even though we're actually at SC25, and there were no new announcements to the top 500 supercomputers at the show or anything introduced over the past year. but there's already been several announcements of new exascale computers that are going to be coming online in 2026 and 2027. I mean, what are the challenges to be able to scale those storage solutions, you know, to that multiple exascale, to be able to scale that to these multiple exascale level solutions?
Absolutely. You nailed the first one, is power. That's one of the biggest issues when you're scaling to that large of a level at the data center the rack level, the data center level. Power becomes a big issue. So focused on leading edge DRAM technology, I'll start there. We're ramping our 1-gamma this year. First in the industry with our 1-gamma. It is 20% better power generation over generation. So it was a big focus for us due to these challenges. And then over on the storage side, again, leading in the NAND technology, the only 9th generation 3D NAND on the market. We can provide memory and storage solutions that give the best power profile for the performance they're getting at that scale.
Well, and I'm just amazed at some of the challenges that we're going to be tackling with some of these supercomputers, from modeling the Earth to, you know, full-on real-time DNA sequencing to, you know, new materials. Matter of fact, there's an estimate that we'll probably have just millions of new materials, you know, that can be analyzed, constructed, and everything else. So exciting times for us in the industry, and definitely exciting times for, you know, enabling this data pipeline to be able to do all this stuff. Are there any other considerations that you think, especially as we look at data center evolution? Because you mentioned power, you know, we're going to 800 volt DC. Matter of fact, at OCP, they were talking about 1500 volt DC. You know, I hail from Motorola, and we used to do very dense computing systems like BME, compact PCI, advanced TCA blade solutions. You know, I think that we're going to go through a revolution in terms of data center and system architecture over the next 5 years. I think we have to, just from the thermals and the power distribution and networking. You know, is there anything that memory has to change to be able to adapt to, you know, whether we go to blades, whether we go to bricks, whether we go to immersion cooling, you know, or even maybe some other exotic solution. Maybe we go to liquid nitrogen. Is there anything else that you see that needs to adapt, and what's Micron doing to adjust to those?
On the memory side, it's that continual advancement of those technology nodes to get that power down, power for performance. Yeah. We have new form factors emerging, so MRDIMM in the market is very exciting for us. You think, well, compared to an RDIMM, maybe it's higher power per DIMM, but then you look at the task energy that MRDIMM produces in a system, and you actually get better metrics of power for performance. So we're having to spin with our system architects the way that customers think about TCO, total cost of performance, total power. So stack benchmarks that we're highlighting here at SC25 are very exciting. I'll focus on one of them with our 9550. It's using not the top-end processor, an SP processor. It's using RDIMMs, not MRDIMMs, okay. Right? So you're not getting the highest memory bandwidth you could technically put in the system, but because it's high performance, high throughput requirements on those application workloads, our 9550 that's attached to that is setting world benchmarks, which is very exciting because, again, it's not just setting record-breaking benchmarks, it's doing it at not the highest cost, an acceptable TCO or an optimized TCO.
So scaling performance, but keeping cost and power a little bit lower.
Doesn't always mean scaling power and cost. Exactly. So you need that memory and storage advisor to work through individual workloads, individual needs. And so we're reaching out, expanding our breadth of advisement based on those emerging architectures. CXL is a great example of that as well, because there's a lot of questions there.
And there's a lot of interest in doing some of the processing, not all the processing, either closer to memory or actually in memory. So, and whether that's in like a GPU attached storage, or whether that's in the SODIMM or SOCAMM or something like that, it's going to be interesting to see how this evolves. I think that memory architectures are going to evolve as much as CPU architectures. You can tell me if I'm wrong.
Oh, absolutely. And I mean, you touched on it there for a second, SOCAMM. Beautiful technology entrance. So we're leaders in the data center space with NVIDIA on LP5X. So for the last 5-6 years, our experience, our depth internally with the LP we're developing and putting into the data center, now leading into introductory modular form factors in the data center, SOCAMM. So we were the leaders in developing that spec and guiding that into JEDEC. And there's a lot more environmental interest of putting LP in the data center attached to different types of processors. So expect to see more LP interest growing in the data center to help tackle that power and thermal issue with acceptable performance specs.
It's not just for your smartphone anymore.
Not just for your smartphone anymore. Exactly.
Tyler, thank you very much. I really appreciate this.